How do you see how many people are in?
A little participant counter down at the bottom.
Yeah, there's a panelist and there's attendees. So we've got 80 so far. 99, 110, 180.
Got it. I see it. Yeah.
Well, I want to give a big shout out to the Colorado Avalanche for winning the Stanley Cup this Sunday. So everybody knows me. I'm a big sports guy. I'm a numbers guy.
That's the weirdest shout out ever. I mean, considering we were in Denver and we're like, how do we get into this game? Let's put some money on it.
Yeah, we were not lucky that day, but that's okay.
No. I'm going to send you a Venmo request for that loss, by the way.
That's fine. Is it cool if I take it off your DAG tab that you owe me, or how do we want to do that? Should
Oh man. We need a running like whiteboard of the things I probably owe you. Yeah.
And vice versa.
Oh man.
Well, I'm going to say that even though I know we're not yet kicking this off, this is, I've been telling all my friends, this is probably one of the most exciting Hypergraph hours in the history of the company. And I know we've probably, used a lot of those bargaining chips saying every Hypergraph hour is the most exciting, but I do mean it. This one is really exciting. So of course it's, always great to see some of the Eng folks' faces on this stuff, considering you're building the mothership. So big shout out to you guys. It's exciting stuff.
Yeah. I don't think you used your bargaining chips. We don't always I remember we got into the rule that I'm not allowed to hype anything anymore, but yet today in Telegram, I went and hyped it. It's like,
yeah, there's been this ongoing joke behind the scenes that you're not aware of, that we tally up how many times you use the word excited and turn it to a drinking game. And we're like, do you think if these were shots, we would be dead at this point? Like he said excited probably 14 times in the last 2 minutes.
Well, I feel loved. I'm going to take that as
hey, it could be worse, could be the F word.
Yeah. No. We're only 1 minute in. We'll give it a few more minutes and then we're going to start on, I think we got a lot of content today. So, oh man. I'm glad that I don't have to present today, really, just a little bit.
Finally, our turn.
I know, thank you.
We get a little bit of time at the end, Ben. It's fine.
A little bit. I got to figure out what I'm going to say then. I haven't figured out.
Try using the word excited a few times.
All right, I'm going to use the word excited.
Keep those numbers up.
Diggles is going to be plastered by the end of it. And there you
Doesn't
go.
take much. It only takes probably 2 exciteds, and then I'm feeling pretty wasted.
Drinking a Peroni.
Lightweight over here.
All right. It's pretty good turnout for a bear market. Yeah. I'm happy. This SP person keeps raising their hand like we're going to call on them. It's like, dude, it's not that type of room. Sorry, person. You can keep doing it, but it's not going to get you anywhere. The new thing on my Instagram is that people send me every day asking for DAG, and they tell me how many days they've been doing it. I think we have somebody that's been asking me for like 80 days in a row. Quite amazing. It's like day number 85 for asking for 250,000 DAG. I'm like, go ask somebody else.
Send them my way.
I was like, I'm going to do the same thing. Like day number 1, asking for 250,000 DAG from you. I need another soft node or node. All right. Well, I'm already jumping along here. All right, let's kick this off. I think we're looking good. We're kind of rounding the corner at almost 400 people. Kind of exciting. It's pretty awesome. For those of you joining us for the first time, this is the Hypergraph Hour. God, I feel like I haven't said that in a while. Today, as many of you know, I wrote in the Telegram channel about how excited I am about this, and really, this going into Q3 this week and next week is such an exciting time for Constellation. Something that we've been waiting for on the sidelines, and watching how the whole space has evolved over the past 4 years that we got started on this. Building awareness over the past several years, and now we're kind of in this engagement and activation phase of Constellation, and it kind of marks a massive shift in the company's direction into articulating product functionality, standards, showing how we are competitive against other people, feature parity, really kind of exciting things for us all to really latch onto. And so I'm not today, while I'm normally the one orchestrating this, or Benjamin Diggles, I am not going to be talking today. So you must all be excited about that. I am, because I've done a lot of talks recently. So today is going to be all technical, going through product. We're going to talk about the Mainnet 2.0 rollout and give an update on where we are. If you remember the last time we did this, Michael Brand presented kind of a checklist on where we are and things that are happening. We're going to articulate, Marcin's going to go through and articulate what stress testing means to the network. What does our network look like? How does it operate? We're going to give product updates. We're also going to have Ryle join us and talk through kind of what an executor is, and how we fit in the ecosystem and landscape. Something we really haven't done on our website through any of our blogs or updates. And now we're going to start rolling this out. So really exciting time, and I'm going to round it out and kind of talk through how this all paints into our strategy going forward for the next several months. So without further ado, I'm going to kick it off to our COO, Michael Brandt.
Hey, everyone. So wanted to throw this up here quick. If you remember, I actually presented this exact slide several months ago. I want to keep the same format, and we're going to keep using it moving forward so we can show progress. This was about 3 months ago. And if you remember, right now we're in the testnet phase. Once this phase is fully complete, we can move on to phase 1 and keep moving through the phases. And phase 1 is the actual creation of the new Genesis flock. So Ben, if you want to hop to the next slide. So a few changes now. We've completed a few of these steps. First one being network stress testing. Marcine's going to do a deep dive on that and some of the metrics around our network. Next up, we've also implemented the testnet rewards, and that is now complete. And now the rest of these steps are currently in progress. So network security audit is ongoing right now. We've already kicked that off over a month ago. We've contacted third-party exchanges and integrations to get them running on testnet. And we've also started creating our L0 documentation examples. So I actually also have another slide later on the L0 documentation and how that's going to be presented to the community. You'll notice at the end, there's one extra thing that we're also going to talk about. Ryle will touch on this. We've decided to start implementing Rosetta support. The reason for that is that's something that actually has core requirements of the protocol. So we wanted to get it implemented now. It actually has a very high impact on how we can integrate with the ecosystem. So with that, I'll hand it over to Marcin, who's our core protocol engineer, to talk about the stress testing we've been doing.
Hey, Constellation community. Let me share my screen. Okay.
Marcin, maybe you give everybody a little introduction to who you are and where you are on the protocol team.
Sure. So as Michael said, I'm one of the core protocol engineers, and I'm working with Constellation for a few years already. I was there during Mainnet 1.0 release, and now we are rolling out the Mainnet 2.0. And that was pretty exciting journey to see everyone growing and to see the community growing. Yeah, today I'd like to show you some sneak peeks from the stress testing the Mainnet network, or the network before the Mainnet release. I will walk you through the process of stress testing, the process of measuring the throughput and the latency and finality time. And I will show you some promising results. I will start with basically the architecture of the network. So what I would like to focus today on is the layer 1 network, which is able to horizontally scale and syncs into the layer 0 network. So imagine that we can have a 3 nodes cluster. So imagine we have only 3 nodes in the layer 1 network, and it's already a network. And basically using such a groups, we can parallelize the process and parallelize the consensus processing, so we can produce multiple blocks in the same time. That's what horizontally scalability means in our case. And for stress testing, we need some kind of repeatable environment. So we have three options to choose from. One of them is the local cluster, and that's pretty convenient for us because we are able to develop and deploy changes really quick to see how the network behaves, how the cluster behaves. We also use the remote clusters like AWS servers or something like that. Basically, we are able to spin up a lot of nodes, like 100 or something like that. And it's still pretty nice and pretty fluent to deploy the changes and see how it behaves. And finally, we have a testnet. We have, as Michael said, we have deployed over 200 of operators there. So we use the testnet as a final check for our basically for all of our tests and processes and things we'd like to confirm. Apart from the environment, we need a pretty high bandwidth availability. I'll talk about that in a moment. So we have 3 scenarios I would like to talk about today. There are many more, but they are kind of long-running tests. Not suits. It doesn't suit into the form of Hypergraph hour. But the first scenario is to measure the throughput under the constant load. So let's say we're sending and spamming with the transactions to the network over an hour or over a day, and we take the average of that and we measure it as a transaction per hour or per second under some kind of load, a constant load. The second scenario is to measure the peak throughput, so the TPS that could be produced as a distributed denial of service, I would say. So would like to spam the network with many transactions, but exactly at the same time. And the third scenario is to measure the latency and finite time. So I would keep, or I would like to send a single transaction to the layer 1 network and see how fast it can be processed by the whole, all the algorithms, and keep it final in the layer 0 network. Okay, so we had the first attempt on measuring the TPS. We used some kind of local network. We used some kind of development PC that was in the same subnet, connected by wire with 1 gigabyte bandwidth. And that was pretty nice. We were able to spam a lot of transactions, and we failed on that. What I mean, we are testing the capabilities of our connection and of our development PC. The network was faster than we are able to spam transactions to the network. So actually, to make a reliable measurement, we need to be able to send so many transactions that the network will not be able to process them. So would have to spin up a lot of nodes or use the community to spam the network or some kind of that. Okay, so the second attempt, because somehow we'd like to measure that. We can move the process of generating the transactions from the from the development PC or from a single place into the network itself, just for testing purpose. And to measure it as a peak throughput, we'd like to aggregate the transactions before processing them by the nodes. So let's say we'll send 10,000 of transactions to the node, or the node will generate that, wait for all the transactions to be waiting for processing, and then start processing. So we can simulate and mimic the, or kind of trying to send all of the transactions at once. And we can test that using pretty small cluster and still have a pretty, I would say, excited results. And let's do the demo time. So what I have today, I have 6 nodes. Each node is under a different tab in my terminal. Those nodes are spin up on AWS. Let me restart the network first. So I will restart all the nodes. Cool. The first node is the Genesis node or the initial validator. So I need to connect or join another node to the first one. Let me do that. Okay. And right now we have the cluster of layer 1 network with 6 nodes connected together. And I would like to generate transactions for 4 wallets, 10,000 of transactions per wallet. So we'll end up with 40,000 of transactions. And let me do that firstly on a single node. We need to wait for about 20 seconds for those transactions to be generated. And then we'll see the logs from the node actually. And in the logs, we'll see the precise timestamp. So we could be able to calculate the TPS. Just a second, okay. We see that consensus pulled transactions, and actually 4 wallets, 10,000 of transactions per each. And we have a block created here with 40,000 of transactions in total. So let's see here the 5th second. That was the very first log of transactions. And the block was created 9 seconds later. So let me see that. We have 10,000 in 9 seconds. We have around 1,000 of TPS. Okay, so let's do what I told you, that we are able to use the horizontal scalability and parallelize the process. So let's create 2 blocks on 2 different nodes at the same time. So on the second node, I will also create 40,000 of transactions. Okay, let me execute that almost in the same moment. And let's wait 20 seconds for transaction creation. And we should be able to see the process of creating the block that is made in parallel on separate nodes. Okay, so the very first node started, pulled transactions. Okay, block created. Let's take a look on the second node. Yep, block created. So this one started here. We have 8 seconds for 40,000 of transactions. And that was on one node, and the second node is here. here we have 7 seconds. Okay, so let's check. We had 40,000 per 8 seconds on the first node. That's equally 5,000 of TPS. And here we have 7 seconds. So another 40,000 for 7 seconds, it's more than 5,000, which means those two blocks were created in the same time. And as you can see, those transactions has been processed in the same time in parallel. So we ended up, or the TPS, we can sum up the TPS. So we had over 11,000 of TPS, and that was on 6 nodes. So I think that it's pretty really awesome and excited.
Marcin,
you know.
maybe for everybody else, I'll give you kind of a 2 seconds here, but
Sure.
for everybody else that's on the call, what this means is we're going away from, you see we're starting to show the advantages of horizontal scalability, that more, when we talk about infinite scalability and infinite throughput, but also increasing the speed of the network, you're showing that by adding each node incrementally is already having a huge factor in how fast it processes all the transactions. So this is truly proving out true decentralized scalability.
Yeah, that's true. And the same we can apply for state channels, as they will also spin up their layer 1 network. So if you want more processing power, you just need to scale horizontally, and that's it. Okay. Okay, and the latency. I've tested that on a local cluster with 3 nodes. But also I've tested that on the AWS and on testnet. And all of those tests were, I would say, similar in case of timing. And we can measure how fast a single transaction can be finalized on the layer 0. So the whole process looks like this. We have some PC, or let's say it's a wallet that sends the transaction to the layer 1 network. So it's a browser, or ledger, or never mind. The layer 1 network needs to create a consensus round and produce the block. And the block is then sent to the, or as you saw, it syncs to the layer 0 network. But the layer 0 network needs to make a consensus as well and agree on the majority and converge the state across all the nodes in the network. And we have ended up with something like that. So that was for a single transaction. And of course, for a more heavy load, you would end up with some increase of these timings. But our goal is, and this is what we aim for, to keep it more or less constant. So no matter how heavy the load is and how many data we are processing, we can scale. So we'll keep those timings kind of close to this presentation. And that was on the 3 nodes cluster, not so good in hardware. So I'm pretty sure we'll be able to pimp it even more and increase the timing and the processing power. That's just a start. Yeah, that's it.
Thanks,
Ben, I
Marcin.
think you
That was
can
amazing.
take over.
Absolutely. If you want to stop sharing your screen,
Yep.
or there we go. And I will share mine. That was amazing. I really appreciate you showing that and walking people through really kind of how horizontal scalability happens. Oh, sorry. Find this slide deck. Apologies for this. Martin, do you want to go through your slides? I'm having trouble finding mine.
Okay, sure.
Yeah. So Martin, thank you so much for presenting that and giving some people like some confidence on what the network is, what you guys are trying to solve and how difficult it is. If it were a linear blockchain, we would have solved this years ago, but because it's horizontally scalable and that we also need to take into consideration local consensus as well as the global state consensus, it's a massive undertaking. Especially when we start to consider the amount of use cases that we're going after, where data becomes a transaction, meaning that the data that we collect is imprinted on the network. And so when you think about going beyond just financial transactions, these are the massive problems that we're trying to solve here. So now I'm going to hand it over to Ryle to give us a kind of update on what the Rosetta implementation is, what that means for us, as well as kind of orchestrating or articulating a competitive analysis to other chains. Ryle, maybe you want to make an introduction to yourself?
Sure. My name is Ryle. I'm one of the engineers here at Constellation, and been around for a while, and definitely happy to be working on this stuff. I've been working on Rosetta recently. Just to give you guys some background into what Rosetta is, it's sort of an open standard, supported by Coinbase and a lot of other different exchanges. It's a multi-network schema and service that follows Open API. Something that makes this super easy to use is that there's a large number of integrations that already target against this. So there's a large number of like wallet applications and other things in the ecosystem that sort of natively support Rosetta. If you're, there's a lot of exchanges that have Rosetta implementations that span a huge number of different projects. There's a huge number of different implementations. And I think this is sort of with, this is sort of our internal replacement for Bitcoin CLI wallet, where you definitely want to be able to make wallet method calls that are not calling DAG4JS or some other external thing. It's sort of connected directly into the node. That's sort of the most secure format. Any exchange or somebody trying to set up a node will really want to get the data directly to run their sort of own local node, so that they can actually check the current snapshot hash, the current hash, to make sure that they're on the correct chain and fork, and then they can get all the data locally and perform whatever operation. Some of the interesting things about it is that it doesn't actually expose any of the keys associated with signing. So the keys are kept entirely separate outside of the Rosetta implementation. The implementation sort of purely expects that you're going to use the construction APIs to construct a transaction, which will talk to our network, get the the appropriate references, and then pass them in. And then when you're doing the signing, it's all essentially done outside of our service, right? So you don't need to verify the authenticity or security of that code. Your keys are kept sort of completely separate from the wallet integration. And it's, sort of the integration is done purely to get prior transaction references and manage this sort of chain state data. I would say, this is definitely a milestone for, supporting, a proper full node wallet, which is super important if you're concerned about security and making sure all of this, sort of lines up. We're at the point right now where we have all the, internal Rosetta tests passing, and we're working on building the indexer out to support more of the Rosetta functionality. It's quite a large standard, so it actually supports, searching transactions locally, a lot of the other things you would expect to see from some of the CLIs of the common crypto projects. Looking up previous transactions, previous blocks, previous, snapshots, all that other information, requires these, indexer and historical balance endpoints. So we're building out the full spec, but we have, the basic transaction tests all passing, and are working on the remainder of the explore, block explorer index type tests. Next slide. So we get a lot of questions about how we're different, what do we compare. Martin talked a lot about the current state of what we're working on right now. I want to try and talk more about the architecture and the sort of future. How do we fit into this ecosystem? But really, sort of to explain a lot of the different competitors and analysis. I think a lot of people, haven't done these technical deep dives on all the other projects. I think there's a huge amount of first to explain what's going on in crypto and how we're different. You sort of have to create the universe in terms of explaining all of crypto. So I'm going to start sort of very briefly at the beginning by talking about executors and Ethereum. So next slide. So a lot of us come from a background of working on Spark and working on sort of conventional code and execution. And there's a diagram here of Spark context and a typical worker and executor task. I'll get into that in a minute, but I first want to start by sort of explaining why Ethereum made the initial decisions they did, which sort of makes sense when you're talking about extending this from Bitcoin, right? You had a scripting language on Bitcoin transactions that you could embed programs into, and Ethereum applications extended that with new language and new internal VM and an executive context that sort of does everything internally, right? You manage code references by referencing other transactions. You manage state internally by sort of embedding them into a state transition or an update. It's very, very similar to sort of a single process application where there is, it's sort of a logical extension of a Bitcoin scripting language to maintain state, but it doesn't really touch a conventional application. You'll see a generic trend in crypto over a whole, over the last 5 years or so towards more generic executors. Like, I think you look at a lot of the people, looking at Solana or Algorand, and their support for Rust executors, their support for in other crypto projects. There's WASM executors now. There's Python executors. There's Java executors. People realize that or they have backwards compatibility where they build out a chain that supports an EVM executor as well. I would say there is sort of this general trend towards adopting and using more common programming languages to write out the executor, the actual contracts themselves. I don't think that there's anything wrong with sort of the EVM stack in terms of that is a great place to start. The problem is that doesn't follow a conventional application programming context. The general trend you've seen towards WASM and Python and Java executors is because it's sort of a lot easier to write out this code, and it follows from conventional trends in other application development. Coming from a background of working on Spark, which is like the largest database engine, I think a lot of that the concepts and functionality there sort of translates naturally when you talk about executors. For people who are not familiar with this, what a conventional executor is it's a way to run a specific task runtime, right? If you're dealing with a concurrency problem, you spawn a task in a local thread or something like that, and you ship that task out. Spark is sort of the first MapReduce program which supports streaming and other operations like that, which allows you to ship tasks over a large distributed cluster. I think a lot of people are familiar with this in the context of, I'm an IBM analyst. We have a Spark cluster set up with 20,000 nodes. I have all of the math libraries and classes registered under that Spark cluster, and I'm supporting, 1,000 analysts that are working on this same cluster, but they share the classes in common to keep the process in memory. This is like a conventional use case for a data pipeline, multi-user, multi-tenant cluster environment. The problem is there's no consensus for untrusted code in those environments, right? You really need sort of multi-tenant executors that can deal with untrusted code that could potentially be injecting, out of memory errors, null pointers. And then you also have the problem of class conflicts, right? You don't have the same sort of situation with an internal company. Like the way these internal companies have their data pipelines set up, they basically have somebody managing that shared class context that a lot of analysts are operating in. They ship out tasks over to executor or worker nodes, and those tasks reference shared runtimes and shared class loader environments. I would say the sort of comparison to ETH here is that they have a shared runtime. You can't really pull in, a lot of classes. They're compiling everything to essentially binaries. So they don't have sort of references across these kind of things. If I'm doing a reference across an ETH transaction, it's not done as a direct class reference. It's done as a reference to an externally compiled class. If I was doing this in a sort of conventional application stack, I would describe this more as something like a workflow orchestrator, right? A function delegation in Ethereum transactions is essentially saying I depend on some data that's been produced by a secondary transaction, which may become loaded under a set of different classes, right? There's a lot of different concepts here that are sort of merged all together in Ethereum, which are not the same in conventional application development. If you had different classes, right, that's what we're trying to sort of mock up as the different L1 zones are really representatives of different classes that can be shared for multi-tenant executors. The combination of, different L1s maps into workflow orchestrators, right? So you typically, if you're talking about something like Azkaban or Uzi, they have, workflow orchestrators for dealing with processes that are using different binaries, using different class paths. If you want, sort of performance on top of that, it's generally not a good idea to, split across different binaries because you can't keep the data in memory. What you ideally need is some way to execute tasks, have them within shared class loader environments, have them referencing each other, and have for when you're crossing these boundaries, these sort of different L1 boundaries, you want to have data interops that can read the schemas between them. This is the general trend in crypto you see with ABIs and application binary interfaces. So everything I'm getting at here is a lot of the problems in crypto. I see them as having sort of native references to existing data pipeline problems. And sort of a lot of the the compromises Ethereum made early on are to deal with the consensus and untrusted code, but there are more sophisticated solutions that you can use that offer greater scalability if you get closer to the sort of original architectures of what these big data pipelines looks like. So go ahead, next slide. So I want to talk about futures and dependencies and things like that. And a lot of people would ask, why is functional programming important here? I think there's a lot of people who talk about who can sort of justify this. On the Cardano aspect, there's a lot of people who are interested in FP for formal verification and things like that. To me, the thing that is interesting about it is the same sort of thing that the reason that Spark and TensorFlow both operate on FP principles, even though they're not written in FP languages, they both separate actions and effects from data transforms, right? So this diagram is taken from Spark, but it applies sort of equally well for any orchestration problem where you're talking about scheduling tasks with workers, right? What we want here is to sort of try and think about replacing function delegates with pipelines. So that means instead of referencing an external function on EVM that produces some code, we want to replace it with a call that's similar to a map function, right? That's an existing paradigm that is present in most applications where you're developing a streaming logic or you're developing, some simple pipeline transform where you're talking about, taking some piece of data, applying some function to it. Workflow orchestrators are great, but there are all sorts of nightmares associated with transmitting data between different orchestration problems. When you actually switch binaries, there's a huge cost associated with serialization, deserialization, not being able to transfer the data in memory. There's just huge costs associated with that, which is why a lot of this stuff is better done as sort of multi-tenant executors, having the orchestration be done as code, and dealing with a lot of these function delegations instead as map operations. And I would hear the criticism that a lot of people would say, oh, isn't Spark for MapReduce and just, bulk synchronous models and things like that. Yeah, there is some of that, but I would say that, there is a streaming platform associated with it. It has been used in that way. And I'm really talking about sort of very generic concepts here that apply to several other frameworks or libraries. And this is sort of the architecture we're interested in, is sort of being able to write applications as though that they were relatively simple regular applications that you would develop for a company or something like that, but introduce untrusted code in there and have a way to sort of verify that that's working. The other huge thing that DAG schedulers and workflow orchestration really center in on is dependency isolation, right? So I only like the entire idea of building a pipeline of functions that you want to run against something and then invoking an action is that you need to isolate when something has a data dependency in common, which is what is required for validation. That's essentially the main optimization for validating transactions, is figuring out what data is in common that is required to verify if this transaction is valid. You don't need to verify the entire universe, right? You do not need to go through and have sort of a global state of everything that needs to be verified. You only need to know what data, where did this come from? If this was Oracle data, if this was something else like that, what came before this? So the parents, the dependencies, or the ancestors. On top of that, you need sort of a solution here for dealing with more complicated future actions, right? So you need to declare, I'm not interested in data that is sort of directly declared. I'm interested in declaring an arbitrary function that maps to some data that will depend on an update to an address. So, the dumbest example of this is I have a call or something, or a put or a futures contract. That depends on the price of some value at some future point in time, which might depend on an update to many different Oracle channels or other things like that. I think a lot of these, state channel examples come from sort of concurrency operations, where you're trying to isolate what dependencies are required, isolate the state to the lowest level that is required, build pipeline or mapping operations off of that, and then sort of declare this as, something that is going to be an action that will trigger these series of workflow operations. That's the benefit of FP, is that you're separating it into a declared action at the end that triggers a series of operations. The next more sort of complicated aspect of this is, how do you deal with multiple networks associated with this? This is something we want to make relatively easy. If you have these things separated into different class loaders or different multi-tenant executors based on who is deploying these L1s and whether they have code that cannot easily be shared or not sort of easily shared in an L0, you need to have the same sort of workflow orchestration be able to span different networks, right? So you need to be able to provide a map function that is the equivalent of a function delegation, which spans a multi-network call to a different network, right? So you're building some operation that is a transformation of an event that occurs on a different subnetwork within the main network. That is the purpose behind sort of microservices. They map naturally to separations and classes associated with different large cluster environments. You might have and then again, this ties into sort of the business reasons behind separation between these different services. If you are building one of these complicated workflow orchestration pipelines, you generally are going to have a large number of different services or subnetworks involved, equivalent to how AWS would work, where you have a file system storage, you have an execution layer, you might be pulling an Oracle service. There's a huge number of different things that you would want to all express as essentially as a code-based pipeline. So, there's a huge number of different subjects I've brought up here. I'm trying to sort of give a very, very high level architecture of what we're talking about and where is the direction we want to go in the future. I realize that was a huge amount of information, but I think that that is a sort of general description of the architecture that we want to sort of aim for in the future, and sort of an explanation for why things are designed the way they are right now.
Ryle, is that all from your side of things?
Yeah, I think
Maybe you can round it out for everybody that's not technical on like why these design choices were made, and what that means for like the use cases we're going after.
Sure. So I think for the use cases we're going after, I think this is essentially, a lot of the ways to solve and support, applications that may not, sort of need to rely on native level libraries that are not available or easy to put or translate to EVM. I think you would find that you have a lot of networks that are not easy to connect together. They may have dependencies that are difficult to jam into Ethereum. You might not want to translate all of the code over. You may have, you may be a company that or a separate project that wants to run their own service, and we want to be able to connect different of these services together. And then you also want, sort of performance and scalability, right? You want the ability to run code against different executors. And sort of provide security and validation to external networks that the code that you're running internally has worked. So, the business use case, I think it doesn't really detract from any of the rest of the statements we're making. I realize this is, sort of highly technical, but this is sort of a generic architecture explanation.
Thanks, Ryle. I really appreciate that. And, maybe we can go to next slide, and I'll kind of translate a little bit of what Ryle's trying to say. Ryle's really giving an example of how we want to create a flexible network and flexible for any use case. And if you look at how myopic blockchain technology and developer tools and standards have today, it really only meets a handful of use cases. And this is kind of expanding so that any developer can really bring their vision, their idea, without having to be confined to the simple use cases of blockchain, 1.0, 2.5, and start looking at collecting data and putting that on a network. And so every data type transaction becomes or every data capture becomes a transaction on our network. And so the only way to do that is create an architecture that's flexible to really any use case that any data engineer will use. Once again, we're not just going after a few use cases around financial transactions, but looking at every data capture as a transaction itself. Michael, are you up? Or Alex, are you up?
Yep, I'm up.
Good.
Yeah, that was awesome, Ryle and Marcin. They do the non-technical stuff. So along with all of the cool core protocol releases, we also want to make sure that everything we put out there is going to be usable by third-party companies and the community. So I'm going to walk through a few other products that we're about to release. The new DAG Explorer is slated to come out in July, so next month. We've completely refreshed the design, and we've done a bunch of quality of life improvements, including things like adding wallet balances after each transaction, export CSV tool, which is going to be great for doing taxes. We're also going to include the Node Explorer directly into the DAG Explorer. And as you can see here, we've enabled testnet 2.0 support and have it ready to enable mainnet 2.0 once that's ready. So everything we need to start going, our internal team is also going to be using the same product for our own development. Hop to the next one. All right, so this is a really critical and crucial piece. This is our documentation portal, also coming out in July. We have this on our staging environment right now. Once this is released, this is what's going to allow third parties to create their first state channels. So we're going to have all of our information from how to integrate with the Stargazer Wallet SDK to running your validator nodes to actually building your first state channel. So as you know, we're currently in the testnet phase. We actually want people to start building their state channels on testnet even before the Genesis block is released. So we can get going now. We have a few folks who have already started. This is coming out in July, and really excited to see what people put together based on this content. Cool. Next slide. I'm going to do just a really short update on Lattice. We're probably going to schedule a much larger update because there's so much happening there in the future. But just for now, a few tactical items. We've actually come out with a release, I believe, last week where we unified the rewards history. So now if you go to your rewards page, you'll see rewards from all the different nodes that you're running, from DTMs to soft nodes to testnet nodes, along with your aggregated earnings. The next thing we're going to release is a soft node restructure. So we're actually just more restructuring the definition of a soft node. It'll now be changed to one soft node per wallet address with X number of shards per 250,000 DAG. So you're going to receive the same amount of rewards as you did before. When you log in, say you had 3 nodes on a single address, that's just going to be one node with 3 shards. We did that as part of the unification process and part of the standardization of everything becoming a node, since that wallet address is the true source of data. Along with that, we'll also be updating the UI and UX for Lattice. You see a little sneak peek of it here. And then in that broader discussion, we'll actually have a whole new white paper to present to everybody. So next slide. Cool. And with that, those are the product updates. And Ben, you want to round us out here?
Yeah, thank you, Michael. Thank you, Ryle. Thank you, Marcin. Amazing presentations. I just sit back here and I'm like so happy what we're deploying. It's exciting stuff behind the scenes, and we're just scratching the surface on how we're really unifying our whole ecosystem. So I thought I'd kind of round this out on, like, now that you've heard the technical due diligence, you see where the network is, and maybe many of you are starting to think of like how massive the potential of this can be, and why we have been so quiet over the years on the technical side, because there's so much being done and being considered, all the way to unifying the productization layer around how consumers access our ecosystem. This to me is some of the most exciting stuff, because we're starting to see a massive shift. On the far right, we're making a massive shift towards building out our developer ecosystem. We've been largely quiet about the developer ecosystem, focusing on the security, stability, decentralization around our network, getting that in place before we deploy developer tools. And this was really by design. We chose to do this because we wanted to come out the gates with Mainnet 2.0 with a truly decentralized network that's not governed by Constellation solely. And once we figured out our speed, scalability, and security issues and aspects, we're now ready and feel confident that we can start to open up that developer ecosystem. We're already working with a handful of teams to start to define the standards that they want to put or integrate at the core of Constellation's protocol, which then can be used by developers through an SDK. So we're focusing on our own NFT standard, our own token standard, DeFi standards, and something that's absolutely critical around identity standards. I think the Soulbound token that came out around a month ago was a really fascinating vision on taking anonymous identity and putting it on chain. And you're going to start to see why we talk about the architecture at length is because something like identity is a very complicated data set that it's very hard to secure on Ethereum. But through our articulation of our architecture, we can really show how we can actually secure or validate the entire data type of an identity on a blockchain. So I'm very excited about this. This is going to be a rolling process that we're really focused on just producing new standards, new use cases, getting third parties to really orchestrate the prioritization of Constellation. And also on product. Our goal over the next year is to ship out as much product as we possibly can. We know what's going on in the space. We're acknowledging how crypto's kind of taken a pullback, but this is the time to build. This is the time to iterate so that when that bull market comes out, we're ready. We're already there to capture more attention, more use cases that have ever been done. And I think Michael's already shown you kind of just an itch of some of the amazing updates coming out. And tomorrow we even have a few more coming out. Not to make an announcement of an announcement, but I'm pretty excited about this release that's coming out tomorrow. And governance. Governance has been largely held close to the few at Stardust Collective, as well as in Constellation. But a lot of our focus to attract new communities and create more network effects will be to create governance standards, create on-chain governance as well as off-chain, and really open up the network to see it flourish in the way that the community fits. And so those are our three primary buckets of what we're focused on. Next slide. And so to round it all out, like, why does all of this matter? Where does this strategy come in? Why does all these technical conversations really matter? Well, it has to do with all of our features of our network. We have an architecture that's built to be elastic for any sort of data type to be plugged through our network, right? We spent a lot of time designing this. Speed, we want to make sure it's fast enough for any use case that can come into our network, not just financial use cases and applications. Security, that's been the utmost concern. We're starting to play around with how do you adjust fees based off of volume of data. We're not there yet, but we're starting to consider that. And all of this is kind of done with parallel work with the United States government and our DoD work. This adds to the layer of security that we're already achieving right now. And decentralization, focusing on creating a wider distribution of nodes that control and govern the network. This will really, really create the first decentralized distributed network. Scalability, more nodes equals more scale. Marcin just showed how that works. If you don't quite understand that, there are people in the community that will help you show how horizontal scalability is kind of the only path forward for all of these use cases. Looking at how you take a data feed and put it on a blockchain is a different type of transaction than the entire crypto space is seeing. And then state channels. Our state channels are meant to be more flexible for more complex use cases. We haven't even seen the next iteration of use cases. And as many of you know, during bear markets, you have an opportunity, there's a huge opportunity where we're going to see a massive shift towards new use cases that invite a new realm of developers that start thinking about alternative applications that can be used in blockchain. And we want to be at the forefront to capture the attention of the future, not the attention of the past. So I can't thank you all enough today. The next, the next couple of months, as we start to roll out the network, you're going to see a lot of these updates in person and in the flesh. And if you're interested in writing standards and being part of working groups, we're all ears. So guys, amazing. I saved 3 minutes. I can't believe we got through all this in 3 minutes. I'm excited about this all. These are some of the best people I've gotten to work with in my entire life, and it's rewarding every day. And it's been awesome seeing how supportive this community has been over the years. This vision is not far out. This is over the next 6 months. You're going to see more rapid development happen than you've ever seen. You're going to see more utility than you've ever seen. And it just makes me so confident that this is the right time to do it. And it took a lot of thought and intention to make this happen. So without further ado, thank you all for joining on the Hypergraph. This was an exciting one. Thank you for showing up. And guys, thank you for the amazing presentations.